Welcome to this online revision session for AQA FP1, in which we'll be looking at the June 2011 question 2 on roots of polynomials. So here we are given the equation of a quadratic 4x squared plus 6x plus 3. Remember, this is saying that A is 4, B is 6 and C is 3 in the standard form of a quadratic equation. And it has roots alpha and beta, and there are two key facts that we need to use. The fact that alpha plus beta is equal to minus b over a, where b and a were two of those coefficients, and alpha times beta is equal to c over a. And the first part of the question just asks us to write down the values of alpha plus beta and alpha times beta. That's the sum of the roots and the product of the roots. And so that's quite straightforward, because b is 6 and a is 4, so this becomes minus 6 over 4, or minus 3 over 2. And similarly, c over a becomes 3 over 4. Fairly obviously there's only one mark for each part here, so that will give us what we require for the 2 marks in total. Next part then says show that alpha squared plus beta squared equals 3/4. So it's useful to remember the identity that alpha plus beta squared is equal to alpha squared plus beta squared plus 2 lots of alpha beta. And so if we rearrange this, we know that alpha squared plus beta squared is equal to alpha squared plus beta squared minus 2 lots of alpha beta. Okay, we have to subtract the 2 alpha betas to get rid of that extra bit when we square the alpha plus beta squared. And so, since we know the value of alpha plus beta is minus 3 over 2 squared, and we know the value of alpha beta is 3/4, we can see that we have 9 over 4 minus 6 over 4. Remember, in 3/4 times 2, it's only the top part that's multiplied by 2. Now we can think of the 2 as being 2 over 1. And so this then becomes 3 over 2 as required. So again here, appropriate use of an identity to get the form that we require to then be able to simplify down and do the appropriate calculations to obtain the correct result. Okay, so that's very much standard work, both parts there. And then finally in part C, we're going to find a new quadratic equation with integer coefficients, notice, which has roots 3 alpha minus beta and 3 beta minus alpha. So once again we're going to calculate the sum of the roots and the product of the roots, because we know those are related to the coefficients of the equation. So firstly, if we do the sum, we have 3 alpha minus beta plus 3 beta minus alpha. We collect those terms together and we can see we're going to have 2 alphas and 2 betas. In other words, this is twice alpha plus beta. And we know from what we did in the first part that alpha plus beta is 3 over 2. So this is 2 times, sorry, it was 3 over 2 negative, I should have said. So it's twice negative 3 over 2 which gives us an answer of -3. And we need to remember that that is equal to minus b over a, where a and b are two of these coefficients in the new quadratic that we are trying to find. Similarly, we can do the product of these two roots. So we need to multiply out this bracket. So we're going to get 9 lots of alpha beta minus 3 beta squared minus 3 alpha squared and plus another alpha beta. So if we collect those together, we've got 10 lots of alpha beta from here and here. And then we got minus 3 lots of, and then we can factorize it, and that becomes alpha squared plus beta squared in there. Okay, once again we know the value of alpha beta from the first part of the question. It was 3/4, so this is 10 times 3/4 minus 3 times. And again, in part B, we worked out that alpha squared plus beta squared was also 3/4. So in total, we got 30 lots of a quarter minus 9 lots of a quarter, which gives us 21 lots of a quarter. And again, remembering that that is related, since it's the product of the roots, to C over A. So what can we use for A, B and C? Well, I can use A as being 4 from here, and C as 21. And then the fact that I've used A as 4 here means that the B value will then have to be 12 to make this part equal to the -3. And so my equation becomes 4, that's A lots of x squared, then it's B lots of x plus C, and that must equal 0. Sorted. So, where are we getting the marks? Well, for working out the fact that the sum of these roots is equal to -1, I'll give you 1 mark. For working out using an appropriate method, the method being the key thing here with the collection of terms after you've multiplied out and factorising it, and then obtaining the correct value will give you an accuracy mark. And then finally, for then working out what values you need for A, B and C, and stating an appropriate equation will give you what you require to get marks 4 and 5. Hopefully you found that solution helpful. Further assistance with your maths revision, please go to the Further Maths Support Programme website.